Thanks. Well, hi, everyone. I'm going to take on a new subject that I kind of been thinking of and putting together stuff for just trying to disseminate some, maybe the word is wisdom, it's a little presumptuous. And it's about libraries. But first, I like to put this picture up at the beginning of many of my talks, just to get people thinking a little bit. And I don't know if we'll tie it in, but anybody here know what this is? Okay, other people? Good, so it's a good picture for here. You want to say what that is?
Apollo 13, the problem of carbon filter.
Yep, that is the Apollo 13 CO2 scrubber, which I don't know how many of you know the story, maybe watched the movie, but you know, they basically went to the moon, had an accident on the way, didn't land on the moon, but had to make it back. And they had to fit 3 astronauts in that little lunar lander thing for a few days on the way. And the CO2 scrubbers were not working anymore, and they had to replace them. But the CO2 scrubbers on the main vessel and the lunar lander were this different shape. So this is literally fitting a square peg into a round hole with duct tape from hundreds of thousands of miles away to save people, right? That is the ultimate duct tape engineering. That's heroic duct tape engineering. And I think it's inspirational in the sense that, yeah, I mean, you don't, hopefully not with people's lives on the line, but when you get to do something that actually, you know, things are in trouble, things are bad, you manage to do something to save the day, there's this feeling you get. And if you get to do that a few times in your career, you're lucky. And there's a lot to be learned from that. One is we get to do that in our profession in all kinds of ways, right? Save the day, do things. But every time we do, there's a lesson to be learned. You should turn back, look at this thing, and say, my main job is to make that never happen again. So great that engineers managed to do that. But hopefully afterwards, I'm assuming NASA did this well, they went back and said the CO2 scrubbers in spaceships should all have the same shape. That's a simple solution, right, to prevent this. And when you do that in your work, and you find that you've slapped a lot of duct tape on your software just to get it to work, take a step back and think about what you should then be doing afterwards, after you finish celebrating, okay? It does relate to libraries, I guess. Yeah, it relates to every talk. Okay, so the subject today is, where do libraries come from? My actual original title was this. That's how I think of it, and we don't really know, but I'll float some theories, and we'll talk about libraries a little bit from my experience, and maybe some others. I see other here in the room I know have built some nice things. I'm Gil Tene, I'm the CTO at Azul Systems. Anybody here already watched my keynote? Okay, so we don't have to say a lot about who I am and how I clean garbage at home. So you saw my previous talk, that's who I am. When we think about libraries, I mean, we could look at all kinds of forms, but the common thing to say about libraries is it's code that other people use. When it's code for you and you arranged it and put a hierarchy and give it, that's not a library if nobody else uses it, right? It only starts being a library when other people use it. And we could look at actual examples that we all recognize as libraries. These actually went to Maven Central and popped up the most popular libraries by the counters Maven Central has, which are surprisingly not much related to what the actual popularity is, but the really popular ones pop up, so we obviously look at these, and you probably run into some of them. But you could look at different areas like libraries for some specific purposes and other things as well. And this is now kind of the end result when they're out there, and you don't have to write them. There's just somebody did it, and you just find out how, and Google and Stack Overflow are your friend, and hopefully you save yourself a lot of work. But there are some key things that I'd like to dive into here about libraries. So the first one is, where do they come from? How do they come to be? What's that process that gets them there eventually? Do you want to build one? Has anybody here built a library that is out in the wild? Yeah. Okay, a few of you. Good. So you're going to call me on my bullshit later. How about the rest of you? Do you want to build a library? Is it one of your life goals or maybe weekend goals? Or you're hearing a talk about libraries. So, okay, let's assume that yes, at least for some. So should you? Is it a good idea? And when does it become a good idea? What are the tells that tell you maybe I should? There's something here. And when it is a good idea, is it going to make it? What does it look like on the way and on the way to adoption? What does it look like when it's actually been adopted? And then, some rules. I'm not going to give you a cookbook, but I'll give you some example rules that only people who build libraries have to follow. People who don't write libraries don't have to follow, so maybe you should think twice if you want to build a library. So let's start with where they come from, or how they come to be. In my opinion, they never start from, I want to build a library. Or I don't think any actual library that ends up being successful comes from there, right? It's not, I want to do a library, what should I do? That's not how it goes, okay? Or I really want to build this and make it a library, There's some examples, people have built interesting platforms, but they're usually a very long set of accidental evolutionary events, I think, that lead to it. And it almost always starts with you doing something, and doing that something again, and then doing it again, so you recognize the pattern in what you do. So you try and make your life easier and make it into a reusable something, right? Because you don't want to keep doing it over and over again. And then you do it for yourself, and then you do it for your group and your friends, and then you do it for your project. And it starts growing. Now, on the way to this, a lot of things may not happen, but if you actually end up getting sucked into doing it that way, you end up doing it for your company or open sourcing it or something like that. And it's really when it leaves the project that it becomes a library. So when you look at other people using it, if they're working with you, it still isn't a library because you're all working together. The actual tell is when something that has no coordination with you is using it. It's not releasing with you. It's not dependent on you. They're not even talking to you, and they're using the code. That's when the dynamics of, okay, I need to package it and have some lasting interfaces and stuff happens. If you can release together, that's not a library yet, right? That's just a package within your project. The fun starts there. Now, there's usually, hopefully, a rationalization step that happens at the point where you realize that that control is going to be gone. That it's no longer the people you know and can coordinate with. And at that point, you will be probably looking at the code and saying, okay, this is what we thought it's for, but it's leaving this control. Let's try and restate the things we've been doing. And you find you rename most of everything, unless you've had perfect abstraction from day one, which most people don't. You probably have a lot of project-specific names that are, you thought this is what it's for, so it's named that, right? This is the thing that counts chickens, And a chicken counter may not be the right name for this abstraction, right? So there's a lot of that will go on, and sometimes in multiple steps. And when you have that use, that's kind of the evolutionary step of whether after this abstraction it makes sense for others. So that's sort of I think it happens organically. Things just pop out because of need, and most of them will die on the way, but some will evolve through this. Now, I'm going to walk through a specific example from my personal experience. There's a library I built. There are many libraries I tried to build, just to be clear, right? But this is one I built that sort of made it. And an HDR histogram, it's up on Maven Central. It's just a histogram, and you got to think, how much can you actually talk and write about a histogram? I mean, it's a histogram. It turns out you could do quite a lot, more than I ever thought when I started. And to give you some feel for what I mean by quite a lot, I wrote an initial library implementation in Java after I went through all those steps that I talked about before, and I rationalized it again and everything. And then there are now 8 other language ports that I didn't write of exactly the same data structure and semantic APIs with a common wireform. And that library is being used by, for example, everything on this list and many others. So does anybody here do microservices in Java? You're probably using HDR histogram, you just didn't know it, because Hystrix and Spring Boot both use it, so chances are you're running it, right? It just shows up at the tiny little useful thing they found to use under the hood, right? So what does this thing do? I mean, great, it's everywhere and people ported it. It turns out it's not that easy to explain why and what it's needed for, so I'll start with a tiny little, what isn't it, right? So histograms are simple things. You count things in buckets, and later you ask how many things happen in which bucket. That's what the data structure approach to it is. Histogram is not a picture. It's a notion of counting what bucket things fall in. And that seems simple until you ask, what are the buckets? Which are the buckets? What size are there? How many buckets? And that's where things get messy, because there are various ways to do it, and it's hard to think of how to generically do it. And every time you will state something, it will be domain specific. Most of the histograms start off with really tiny, trivial inline code examples. They don't even deserve more than an array and a few methods, maybe, right? And there are 2 main forms. There's linear implementations, like, everything up to 100, everything. The sizes are the same, so they're linear. And that's really simple to view and understand. You just, divide by the size, stick it in the thing. Later, you'll find out what it is. That's good for some things. But for example, if you wanted to cover numbers from a microseconds to an hour, you would need 3.6 billion linear buckets. That's a little too much for today's computers. So the next things, obviously, people do is, okay, we're not going to go linear to an hour. We'll do logarithmic, and then you do, powers of something. And that works great, because you only need a few tens of buckets to cover pretty much any range, but you have this problem where you can't really tell the difference between a second and 2 seconds or something like that, and that annoys people, right? You have nice resolution here, but then you see the numbers, but no, I want to understand more, and it's not there. And then people do ad hoc histograms where they choose the boundaries, because they say what's important and interesting and stuff. But because of this, there aren't that many libraries for histograms. They're either trivial or they're messy. HDR histogram is explained fully here. That's the actual, Java doc 1-page stuff. But simply put, it's a data structure that can track an arbitrary range of integers with a prescribed resolution, with a precision that you state. So for example, you could say, I want to track that range with 3 decimal points of accuracy. And that's how you're going to say it. And what that means is that you can track at 1 microsecond resolution all the way to a millisecond, and a millisecond all the way to a second, and a second all the way to 1,000 seconds. So you're plus minus 0.1% at any point in your value system. I actually use 2 decimal points almost everywhere, because that's enough for a screen. Plus minus 1% is usually more than we need, but it's dramatically better than what a logarithmic thing does that just annoys you, and it's a contained fixed size, right? It's fast. Like on this laptop, I can record 200 million values into a histogram per second. That's faster than I can measure time on this laptop. So if you can measure time, you can record histograms of time, okay? That cheaply. Said that. It's designed to be 0 allocation, so if you're in a very performance-sensitive world, especially if you're doing many, many operations a second, you don't have to worry about this blowing up and resizing and stalling, and it's just constant speed access, O of 1 axis with no side changes, unless you want variable size structures, and some people do. And it's got a common wire format. Everybody shares it across languages. It's got all kinds of nice convenience things, like recorders that let you do concurrent recording and then samples of intervals for logging, and it's got a common log writer format and all kinds of stuff. And there are viewers that'll parse your logs and show you pictures of them now. So all that's there and cool. And for the monitoring systems out there, this is one of the things that happens to libraries. People come to you and say, this is great, but this is my problem, right? So one of the problems people came to me with from monitoring systems is people give us numbers. We have no idea what the units are. We don't know what the range is going to be. I can't use this API that tells me how much. Can I just have a histogram of all the numbers with this resolution? And I start off by saying, no, it's a little hard to do that. But my favorite thing of doing is every time I say something is impossible, that's a weekend project, right? So it turns out you can do a double, like floating point double histogram with no prior statements on what it's going to be and say what the resolution is, using HDR histogram for integers under the hood with shifts and resizes and all that. Now this will do resizing and reallocating, but it basically auto ranges within the range of double, and it could cover a dynamic range of the entire long range, so 2 to the 53 or so. It won't cover the entire 2 to the 2000, the double does, but unless you, within your numbers, have a range larger than 2 to the 50-something, it's going to be right, and it's going to work. So great, it does that too even now. Anyway, let's pull out of that. Great advertisement for HDR histogram, but HDR histogram is a library, right? That's the point in the talk. So how did it come to be that? How did it evolve there? So it started off as an inner class in something that was called JitterMeter. JitterMeter later became JHiccup by throwing away 90% of the code and giving it a cool name. But this was just about 100 lines of code in there. I had a problem to solve. I needed to do this cover time in a wide range and do it fast and easy and report on it later with resolution. So I wrote some code to solve the problem, and that's it, right? And later I found needing to solve that problem again and again, so I just kept copying my code out and use it in some other tools. And then, I made a class out of it, and then I showed it to a friend. And, the next thing I know, I'm running a yak shaving co-op on GitHub, where I put in a Java-colored human in yak, but now lots of people put all their breeds and colors and stuff like that on there. So somehow from that point to that point, stuff happened. This is sort of the project page with the different things and the GitHub thing, and the first commit to this, the first commit where you could say that's when I recognized it's a library, mainly let's put it up on GitHub. I didn't have it up there until then, is about 7 years ago, right? It probably baked for about a year and a half before that. We don't even know that this is a library form, right? And this was the first attempt, right? Like you put it up there, I don't know what'll happen with it, and you could sort of see the version history there. Like I said, GitHub's usages are not actually that indicative, because when people move forward, you lose the old one. So I don't really know what the adoption rate was in that, but it made it into lots of things. And again, those counts on numbers of projects, some of those projects, have the internet uses. So it's pretty heavily used by things like this, if we ask the stuff. Okay, so there's this evolution, and I'd be happy at the Q&A stuff, and I'll try and leave some room for the Q&A to just answer questions about experience there. Do you want to build one of these? So, you got to be careful what you ask for. What do you like to do on your weekends? Because if you don't get paid to do this, this is going to be your weekend, right? Now, you could also ask the question, can you get paid to do this? In some places, like, Guava is being, Google does Guava, right? But do you want to be doing this as your job? That's another key question, because a lot of times, most of us, I think, that have built these, have built this by accident. This is not our job. This is not our main occupation. It wasn't even something we said we want to do. It was sort of an increment of the right thing to do at a time, and this is where we are. So think hard about whether you want this. And if you do want this, you want to prepare for some real reality. For example, it's 2019. Are you willing to code only in Java 7? Because I do when I write a library, because some people use it with Java 7. Actually, until earlier this month, I coded in Java 6. Not this month. In January, I released the last release of HDR histogram that will run on Java 6 so that I can stop writing in Java 6. And it wasn't for me to write it. Really, 6 to 7 is not that big of a difference. There are other reasons in tool chains I did that. But when you do this, and if it gets adopted and it lasts, you will not be moving that code to modern stuff. Just be very aware of that. There's a responsibility when you write libraries to do that. Now, is your library a good idea? I have no idea. And one of the motivating ways is to ask, why is it needed? So for example, is it just because you really don't like the 7 other things that do the thing you want to do? That might be a legitimate thing, by the way. Sometimes implementation 8 is the golden one. Or is it because there's an actual missing something that you find yourself having to do because it doesn't exist, right? So the best positive indicator, the best hint, I think, that exists that there might be something there is that some other person copies your code, not because you made them do it or because you pushed them towards it. They actually want to copy your code. That's a strong hint that there's a multi-person need for this code to exist. And then, will it make it or not, there are a lot of paths along the way that it could go wrong. So for example, I do think most of these things die young. Most of my GitHub repos die young. That's their job, I think. I think that for every star and fork on GitHub, I don't know how many things die. And that's as it should be, okay? So don't get discouraged. If everything you try is gonna get have the internet to use it, then wow. But most likely on the way, there'll be a lot of things that are dead ends. Also, don't get your hopes up, because most of these things will fail. So by not getting your hopes up, hopefully you won't get discouraged later. And try to do a good job from the start, from the point where you offer it out as a library. And think of what people are going to expect and need from your library that you haven't yet had to do. So I'll give you some examples of these rules. So a simple one is API compatibility. We're not going to write this once and throw it over there and it'd be done. You keep doing and tweaking and refactoring, and people ask for enhancements, and you find bugs and you reshape things. But once it's out there, once people have started using it, their expectation is that they can get a new version and not break their code. And you need to be careful with that, not just in maintaining the APIs, but also maintain the binary compatibility of the APIs. One of my favorite examples is, when default interfaces were introduced, there was this really interesting, that seemingly you'd say, what are the chances? And the chances ended up being really, really high, that adding a default method to an interface would break existing code. The most common examples with that would be things like you have some interface lists for other things, and you say, well, let's do a thing that counts the size if they don't already have one or something, right? You think you're adding a missing method, and it'll get overloaded if other people have one, but it turns out that when we think of the right name to a method, everybody seems to think of the same right name. And what we often don't do is agree on the types. So if you add a default method that takes an int, somebody else had a default method that took a long, you just stole their method from under them, right? So when you put in an interface, adding a method to it later could break your customer's code if you add an implementation, not just an API. That's just an example. There are many binary examples, and actually, there's in OpenJDK there's a CSR group that does a lot of these for the JDK itself because it is full of libraries. The sort of the inspection of what surprising effects, what binary compatibility effects might be there, and it is something useful to go look at if you're considering rules to go by as you add new code. Go look at the CSR work in OpenJDK. Just look at the experience gain there. You don't have to go through their process, but look for the examples. So one of the things is if you're putting new code out now, you could be courageous and say, Java 12, that's what I'm coding this to. It's for Java 12, I'm coding to the future. But don't expect a lot of adoption, okay? If you are putting out a library today, you probably want to be able to have a lot of people that actually do coding today use it, so you'll have actual indicators. And today means not just what is kind of the coolest thing you heard in a conference this week, but I would roughly say go for whatever the mainstream, pretty much everybody was coding to 3 years ago, and you'll be about right. Because if you go to what everybody's coding to today, seemingly, more than half the world can't use your code yet. And that's probably the half that needs it. So you're going to start roughly there, right? You can't start to the latest about to be released thing because nobody's going to use it for a long time, and that will hurt you. So aiming for the language, aiming for those is there. I know several people who started libraries for Java 8 in the year after Java 8 came out, and actually got eventually the things to take, but it's clear that if they started at Java 7, they would have had much more accelerated adoption at the time. And by the way, when I say right to that, I don't mean prohibit the use in those or don't use cool features. I've written libraries in Java 6 that have functional APIs intended for Lambda expressions. So think of your customers that are using modern stuff. It's just what you can code in is limited, and you have to play a little bit of that game. So I write my tests with inner classes, but you get to use Lambdas, okay? So if somebody starts using your library today, they'll hopefully keep using it, and you have to remember that they might not touch their code for a while, but every once in a while come and upgrade, so they're not going to shift versions. In practicality, what you should be prepared for is if this lasts, you will be coding to a language version that is 7 to 10 years old, right? Because you started with one that was 3 years old, and it's aging from that point, and you can't push stuff out. I just did the last Java 6 last month, and I actually think that I was torn on this, okay? The reason I did Java 6 is because Maven test stops work. So the reason I stopped Java 6 is because Maven test stops working on Java 12 when you produce Java 6 jars. And I didn't have the time or the patience to figure out how to work around that. And I wanted to make sure it runs on 12 and 13. 11 was fine still across testing, but so I decided to sunset 11 so I'll be ready for 12 and 13. But, sunset 6. 6 is sort of done end of last year. We're dealing with the last kind of, people using it, and nobody's going to give you updates after this year, so, you're probably okay to abandon those two. Okay. It's hard to get rid of this stuff once you put it up. So I'll give you an example of a GitHub project I have. This was done in 2 weekends by me and Mike Barker. He was on a plane half that time. And we basically took WRK, which is a really popular load generator, and somebody pointed out how to use it, which was a problem. So we created a WRK2 with a fix. I did it mostly as a demo for a workshop I was doing. And we put it on GitHub and pointed to it and clearly said it's an experimental development thing. And see that? That is actually more popular than HDR histogram. And Oh, it's only 32 issues. I thought it was a lot more than that. But I don't maintain this thing. I've said from day one I don't maintain it. Other people here and there have done stuff and I've let them put stuff in. But it's out there. People use it. They love it. They come and talk to me and I tell them, okay, it was a demo. I didn't mean for anybody to use this, right? This was an example of how to fix something, not please run this as a load generator. So be aware, right, that once you put stuff out there, it's really hard to get rid of. I can't take it down. People like it, right? But I don't spend time on it. This is another project that I did, latency utils, that uses HDR histogram, and I thought it was dead. But it turns out, see, I haven't touched it in about 4 years. But it turns out that all these things actually use it. I recently started searching, right? So can't take it down. That one, by the way, I haven't yet checked to see if it runs on Java 11, so I guess I need to go do that. And issues will pop up all the time, like, does it work on Java 11? Because you know what? Most of Maven Central doesn't just work on Java 11. You have to go do some work. It's usually not super hard work, but it's there. And what about 12? I just gave you an example. I had to kill 6 to do 12. I'm hoping somebody will come up with a little cookbook on how not to kill your 6 and still do 12. I couldn't find one, and I really needed to test for 12. And then can you keep it working on both of these versions at the same time? And this seems like an interesting question now, because why 7? If you're doing a new library, fine. But just think of it for the future, okay? You're going to do 8 if you do it now, right? And are you going to keep supporting it when Java 23 is out? That time span is smaller than 7 to 11, just to be clear, okay? So once you do this, how do you keep the code working across that span? How do you even do the testing for that? Travis actually is kind of nice for that, but you know, there's some things you can't do those. So I'm going to give you a few examples of what I've gone through to keep my stuff alive. Again, HDR histogram is probably the one I pay the most attention to because it's the one with the most actual impact. When Java 9 was just about to come out, somebody opened a ticket on HDR histogram that it doesn't work. And I kind of shrugged. I knew what's in Java 9, but I knew I was doing good, responsible, pure Java, only to the spec coding. I wear a lot of hats. One of them is admonishing people for doing otherwise. So why did it break? So I went to look at it, and I fixed it really quickly, but that broke Java 7, right? So then I went through this labyrinth of, okay, so I need 7 and I need 9, and what happened here? What actually broke is the wire format for HDR histogram uses base64 encoding. And who here has written their own base64 encoder? Oh, wow. I expected, well, good for you. Well, maybe I should have borrowed that. But in case you don't know, the JDK has a few of them. Most of them you're not supposed to use because they're like sunMISC something, but there's a spec one. It's sitting there right there in the Java, in the XML stuff library. It's in the Java SE spec. It is the right way to do base64 encoding in Java, or used to be. So I used it. And Java 8 introduced a new base64 encoder, much cleaner, java.util.base64. Now that's the right one to use now. I didn't shift because Java 7 and 6 and 5 don't have that, right? But in Java 9, they took away the old one. So the fix to move it to 8 breaks stuff. So how do I do stuff to sit on both sides? It turns out that people have proposed all kinds of really cool things, like, have you heard of multi-version jars? Really, really cool stuff until you try and use it. It makes for really nice demos. I fully implemented a fix in multi-version jars. It worked across every version. And then I thought about it for a while. And then I threw it away. Because it required multiple source files for the same class. Java doesn't have ifdefs. I was not about to create a dependency on some templating library. I have no dependencies in HDR histogram. And I'm not about to carefully duplicate my bugs across every source code that I have to do this in. forever because I have things to do on the weekend other than this. So I just threw that away. That's just not maintainable. That's my opinion on generally on multi-version jars. It's a really cool demo, but then what, right? So I looked around for ways to deal with it, and I eventually built a helper class. And this is kind of the, if you guys have this problem, here's how I solved it part, right? Now, would I have done this work if I had dependencies that were broken? Probably not. Like if I used your base 64 and it was broken, I'll wait for you, right? I actually think of Maven Central standing in a circle right now waiting for other people to do stuff. I just happen to be a Leaf library, so I didn't have an excuse. And let's try and kind of tell you how this worked. The problem is really library portability, and I think we might even have an idea for a library for library portability as a result. And so basically, you need libraries to run across multiple versions of Java, but Java has now started doing aggressive deprecation. They don't think of it as aggressive, but it's aggressive because Java has never ever deprecated before, so anything you do now is aggressive. Basically, you make use of an API that stops existing. How do you keep your old stuff running but still run on the new stuff? That's effectively the problem. And multi-version jars don't work that. Split source does not work that. A good fix would be to encapsulate the problem area. That's what I ended up doing. So you find the problem stuff. You say, why did they break my stuff? But okay. And then you encapsulate it and keep all the ugly stuff in one place so that everything else doesn't look so bad. And then you can use all kinds of tricks with reflection and method handles to make the code work either way, and maybe even make it go fast. So here's the actual example for HDR histogram. I basically needed these two things. This is the nice big Java doc I put on my internal Java helper. This is a class inside HDR histogram, and this is the actual way you end up using it, where I'm using a method handle invoke on that stuff, an encode method invoke or those, right? Now this is the ugly part, but you can hide it, right? So it's ugly. You kind of don't after you finish coding this, you want to go wash your hands. But put it aside, and then other people don't have to sit in this one file. All the rest of your code is nice and cool. So, that's what I did. It's sitting in HDR histogram. If you have this problem, just go look at my base 64 helper. Not for base 64, but for whatever else you have that broke this way, that you need multiple versions of, okay? So I can't be the only one that ran into this, right? Because you know what else uses base 64? JSON. And the JDK doesn't have a JSON parser. So I guarantee that all the JSON parsers that existed before broke, and hopefully some of them have been fixed. And this is just one little sample. And remember, I'm not somebody who used Sunmisk unsafe for anything, or the other things out there. Okay. So another example is the reverse of this. So you know something is coming. You want to be ready for it, but it doesn't yet exist. So you want to future-proof your code, and you want to encourage other people to code to the new thing. Basically, you want to be able to run on a current JDK and on a future JDK, and only use the feature if it's there, kind of stuff, right? And there's an example of that I'm to blame for, sort of. I actually managed to get a feature into Java 9. I went through the whole JEP process, and part of the motivation was I wanted to actually prove out the process, see what it takes to really put in a feature, because everybody complains. I said, let's do it, see what it really takes. And the other part is people really wanted this feature, so I got it in. Now, this is the entire Java 9 contribution here. And notice what it is, right? That's what it is. That's the entire code. There is no secret anything anywhere else, right? It's an empty method. Does nothing. Or doing nothing is a valid implementation, okay? The Java doc is what's important. It's a contract. It's what it is doing, what it's hinting, what doing this means. On spin wait is something you put in a hot loop to tell the JVM you are spinning, and maybe it could do things to make it better. And it turns out that it can. By putting the x86 pause instruction in the loop, you will wake up about 20% faster out of the loop, and you'll burn a lot less power, and your clock will run faster on other cores. It's good for everybody. Every spin lock in the world uses the pause instruction in x86. Java was the only language you couldn't express that in. So Java 9 allows you to do that now. Great, that's the contribution, but it's in Java 9. How do we get all that massive libraries to start using that? Because nobody runs on Java 9 yet. Java 11 eventually will have it. So I know Martin Thompson. I asked him for some room in his library. We didn't make a library for this. And inside Agrona, we put a thread hence library method. And the thread hence method does this. So Mike Barker, again, came up with the nice method handle stuff for that. But basically, there's an on-spin wait in there. If you use org Agrona on-spin wait, it'll work on any JDK you can run it on. Sorry, on any post-Java 7 JDK you can run it on, because it needs method handles. And if the JDK doesn't know how to do anything with on-spin wait and it doesn't exist, then it will be a no-op, which is a valid implementation of it on-spin wait. But next time it runs on a Java 11, it'll suddenly run better. So that's what org Agrona does, and then this is stuff that uses it. For example, that's Agrona itself. No, sorry, that's Agrona. But then, anybody here use the disruptor? So it uses that now, and several other stuff. So actually the most common user of on-spin wait is the JDK itself. All Java util concurrent uses it under the hood now. But you'll start seeing libraries use it. The problem, all those libraries have the problem of how do I code to something that's only in Java 11? Now they have an API that they can code to, and it'll be nice and fast in Java 11, but run on any JDK. Usually doing this kind of trick, you need to find a home for it. This is a good example where I wouldn't build a library for this. It's one empty method, damn it. I mean, we put it in the thread class. So I probably wouldn't put up a Maven Sertra library for this hint. But you can piggyback sometimes on something else, reach out and find room for it. Okay, so my next idea for a library, just to get ready to wrap up and do a couple questions, I'm thinking of doing a library called Safe. Okay. Meaning like org Java portability safe. Safe would be the thing you run to do all the unsafe things you do, but it's safe. Now, how is it safe? It'll actually be safe on Java 11 because I will use var handles to do all the stuff you want, and on Java 8 I will use unsafe. But you can now start coding to safe. And then you lose all the excuses of I can't move to the things because it took unsafe away from me at some point, right? And it should actually help the code. So this is my, maybe I'll do stuff on the weekend. If there are other people who want to help and contribute to that, please come and we'll chat later. But again, this is one of those, maybe we can help a lot of other people improve their code and future-proof their code so that they can do better. So that is my last slide. Are we on time? 7 minutes? So let's do some Q&A and see how much, it's nothing like you said kind of stuff it is from you guys who actually build some libraries. Yeah.
Did you see this talk this morning regarding with the matrix multiplication example with value classes?
Matrix multiplication with value types. So I have to be honest, I haven't seen any talks today because I was making these slides.
But basically they used a new feature in Java and it sped things up like 4 times and reduced memory footprint by 1,000 times or something.
Cool. So this is a value types example.
Yeah.
Okay, so this is a new feature that might someday come up in Java.
Right. So
Yeah.
if this version comes of Java with this feature and it's killer for HDR histograms, what would you do? How would you handle that?
That's an interesting and tough question. Um, Forking my own code internally is a very tough thing. And it is very tempting if you can actually get some extreme speed to actually multi-version your own code and have the if it can do this and if it can't do that. But it creates a maintenance nightmare going forward. I've had to do a lot of interesting abstraction inside HDR histogram myself because of all the things people have wanted. So for example, HDR histogram has a histogram. Well, that should be obvious. That it does long counts. But then people said, some people run hundreds of thousands of histograms. They want to do at least footprint, and they never count too long. So there's an int histogram and a short histogram. Fine, okay. And then there's an atomic histogram, and there's a synchronized histogram, and there's a concurrent histogram. And now on the way here, I was starting to work on a packed histogram. This never ends, by the way. Just trust me if you get into this. Yeah. So there is all kinds of variation and implementation already, and you might be able to build the right abstraction under the hood for you to have two implementations on there. And if you do it right, it may not be a forking, like a duality of code, right? You put the right abstraction, you only do the implementations you do differently. Usually for data structures, that's doable. So if you look inside HDR histogram right now, the simple unsynchronized ones have just a flat array, but the concurrent version has two different arrays flipped with a phaser. But the APIs and abstractions for all of them are the same. So I would probably follow something like that in design.
Would make maybe fast histogram?
Yeah, it would be tries to be the right speed for the platform you're on histogram. Does that make sense? And whether you expose that as a hint, as a control or not, that becomes a question. It's a value call at that point. I try not to expose too much when there's an obvious answer. But for example, packed versus not, that's a big, do you want small footprint or do you want blazing fast recording? That's a choice, right? Concurrent versus not, all those kind of things. There's cost to things. Space and additional, like the concurrent version is probably 3 or 4 times slower than the non-concurrent version. It's still tens of millions a second, but some people care. The other interesting thing there is, as you noted, this is value types. Value types are being developed in Valhalla, which is really cool, but we don't know what version of Java it's going to hit. It's certainly not going to be 12. That 12 is a month away. We know it's not there. If I had to guess, it's probably not 13. Maybe 14. So if you want to start coding to this, what do you do? Because you can get your hands on a JDK that'll do this, right? It's just nobody's going to run it. So you can start preparing for it, but you have this future-proofing question, and maybe you find a way to abstract it away or whatever it is. Value types I actually think might very well fit. For example, in structures, they might very well fit in a way you can abstract. In that sense, I think they'll do well. But this becomes a question every time, for every new cool feature, and it's there. And remember, one of the things is writing, if you're running your own application, you can use that JDK now or next, or get ready for it. It's about to be released. Your code only needs to really work in 8 months. Go for it. But when you're doing a library, you don't get to make that choice. You want other people to use your stuff, they're not going to move with you. Other questions? Yeah.
Do you have any opinions on what the library shouldn't do, like logging or stuff like that?
I don't really have strong opinions of those. I believe in evolution. So libraries that do stuff they shouldn't be doing basically don't get strong adoption. So people learn. Look at what others do. Think of what you wouldn't accept as a customer. There's there's the golden rule. It works really well in writing libraries. But I don't think there's a prescribed set. There's probably a set of wisdom if people tell you that I did that didn't work out, don't do that. But I don't think there's a rule of just don't. And if you get somebody to accept a library that logs, like log4j, maybe, yeah.
I wasn't thinking about the logging library. I was thinking about libraries that log behind your back.
Yeah. One thing I would say is dependencies are a sticky thing. So on the one hand, you don't want to be writing everything yourself. You shouldn't. Why did you guys do this Space 64 class? I mean, you had some need, right? But if there's one there, don't, right? But at the same time, any dependency you create on things that are not the platform adds a lot of complexity and sensitivity to you and your customers. So I've managed to make a zero dependency library in HDR histogram, but that's because I've kept functionality very small. For HDR histogram, it's probably for recording latencies and time, but it doesn't know what the unit is and it doesn't care, and I'm not about to put nice, clean things that let you print it as time in there, because let other people do that. And people have wanted me to use JSON in my serialization format, and my answer has been, when the JDK gets a JSON parser, I'll do that. Because which of the 17 JSON parsers should I use, and what licenses do they have? And are the people currently using HDR histogram okay with those licenses? It's not my call, right? It gets very messy, right? Once you have adoption, adding a dependency has huge implications. Some people can't consume some licenses. I went with this, I would prefer a permissive license, meaning open source, but don't tell people what to do with it kind of license. I'll accept other stuff, but I try not to have my library code have place license requirements on others, because I think that dramatically reduces the adoption of the library. Right? Okay, well, there's a 0 here. So with that, I'm done. Thank you very much, and we can chat at the quarter later if you want. Okay.